Hello and greetings to everyone. Myself, Harshit Pal, final year BTech Civil Engineering student from Faculty of Engineering and Technology, University of Lucknow, will be presenting a seminar on the topic 3D printed buildings. Here's the table of content and the order in which I'll be going on with my presentation. At first, I'll be giving a brief insight about 3D printed buildings. Then, I'll be giving an overview on the same. After this, we'll discuss about the various components used in 3D printed buildings. Subsequently, I'll be telling about the additives and admixtures used in 3D printed concrete, following up with specialized materials used for the construction of 3D printed buildings. After this, I'll be taking up two case studies of 3D printed buildings, following it up with conclusion and references. In this slide, I'd like to tell about the concept of 3D printing. It is a process in which digital models are transformed into three-dimensional objects. This technology has redefined almost every major industry from manufacturing to healthcare. In the field of construction, 3D printing is done by using large-scale printers to extrude materials, generally concrete, from the nozzle. 3D printing eliminates the reliability and requirement of framework, simplifying and smoothing the construction process. This simplification of construction process leads to the construction of complex structures with ease. This method is extremely time efficient and the generation of waste is significantly low than conventional buildings. In this slide, we'll be enhancing our knowledge a little more about 3D printed buildings. 3D printed buildings are the architectural structures made by layer to layer deposition of materials, generally concrete, without the need of conventional framework or molds, helping us to deal with long standing challenges like labor shortage, material waste, and design limitations. Extrusion based printing, power bonding, and robotic arm printing are the methods used for construction. In extrusion-based printing, the extruder moves in x-axis and y-axis, depositing the concrete layer by layer from the heated nozzle, whereas in robotic arm printing, the arm could move in six different directions. In power bonding, the powder is kept at a base and the powder is heated up to its melting point, and the design is generated layer by layer through the heating of powder, constituting the design of the construction. This slide consists the basic components used for 3D printed buildings. First and the most important material is cement. Crucial factors like printability, strength, and durability significantly depends on the type and the quality of cement used. Portland cement and blended cement are the most commonly used for 3D printing. Second is aggregate. Aggregates such as sand, gravels, or crushed stones make up the bulk of the concrete mix and are crucial for providing strength. Fine aggregate is generally used in 3D printed buildings. Third is water. It is crucial to maintain water-cement ratio for the construction of 3D printed buildings as it directly affects the workability, settling time, and the strength of the mix. It is generally kept in between 0.3 to 0.5. This slide consists of the general additives and admixtures used in 3D printed buildings. First are superplasticiers. They are used for enhancing the workability of the mix. They help in the water reduction and improve the surface finish of the building, enhancing its aesthetics. The examples are polycarboxylate ethers, also known as PCEs, and sulfonated naphthalene formaldehyde (SNF). Second are accelerators. These are used to reduce the settling time in cold conditions. They enhance the buildability and provide early strength of the mix. Examples are calcium chloride and non-chloride accelerators. Third would be retarders. These are used to increase the settling time in dry conditions. They help in improving the surface quality of the structure. Examples are gypsum and lingosulfonates. Fourth are fibers. These are used to enhance the tensile strength, durability, and making the structure crack resistant. Examples are propylene fibers and carbon fibers. The specialized materials used in 3D printed buildings are: first, printable cementitious composites. They are specially formulated materials used for 3D printing. It is a combination of traditional cement, polymers, fibers, and other additives. They are specially formulated to enhance printability, durability, and mechanical property of the structure. It helps in printing customized structure, rapid prototypes, and functional prototypes. Second would be concrete, which is further divided into two. First is fiber reinforced concrete. It is a composite material that incorporates fiber into the concrete mix, helping to enhance the mechanical properties like strength, toughness, etc. Examples are steel fibers, propylene fibers, and glass fibers. Second is self-compacted concrete. It is a special type of concrete that can flow and compact under its own weight without the need of vibration. It has high flowability, excellent surface finish, and reduced segregation of aggregates. Now, I'll be taking up my first case study, which is Dubai Municipality 3D printed building. The project location was Dubai, UAE. It was completed in 2019, and the technology provider was Apex Core, an American-based company. Area of the project was 640 square meter, consisting of two floors. The purpose was to demonstrate the capability of 3D printed buildings for large scale. Material used for the construction are listed as follows. OPC was used as a primary binder and was supplemented with fly ash. Fine sand was used as aggregate. Water cement ratio was kept 0.35. Sulfonated naphthalene formaldehyde (SNF) was added to improve the flowability. Propylene fibers were added to enhance the tensile strength and prevent crackling. Here mentioned are the project outcome and material impact. First is printability. The material was efficiently extruded by Apex Core mobile printer, creating walls of 9.5-meter height. The balance between flowability and integrity was critical for the building's success. Now, I'll discuss about the structural performance. The inclusion of propylene fibers enhanced the tensile strength, resisting minor cracks and deformation. It was extremely important given the building large scale and complex geometry. Now, we will discuss about the sustainability of the project. Supplementing OPC with fly ash reduced its reliance on cement, known for its high carbon emission. The workforce consisted only of 3 people required for the construction and management of the building. The project was completed in 60 days of 8 hours work on each day. One of the major challenges faced was to find the right mix that would set quickly enough to allow continuous printing without deformation. Now, I will be taking up the second case study, which is New Story and Icon 3D printed housing community in Mexico. The project location was Tabasco, Mexico. It was started in 2020 and the technology provider was Icon. The area of each house was 500 square feet and a total of 50 houses were constructed. The purpose of this project was to create sustainable low-cost housing solution. Material used are listed as follows. Proprietary lavacrete was used as primary binder, fine sand was used as aggregate, water cement ratio was kept 0.3, microfibers were added to enhance the tensile strength and prevent crackling. Now I'll be mentioning about the project outcome and material impact. First is printability. Icons Vulcan second printer successfully printed the houses using lavacrete mix. The fast curing properties of concrete allowed for quick layering without sagging or deformation. Now, I'll discuss the structural performance of the project. Microfibers in the mix help the homes to achieve necessary structural integrity to withstand the region's seismic activity. The homes were designed to be earthquake resistant, an essential feature of the buildings in rural Mexico. The use of SCMs reduced the amount of cement required in the mix, lowering the environmental impact. The home built were 30% less expensive than the conventional buildings, making home ownership more accessible for low income families. A single house was constructed in 10 days of 2.4 hours one day machine work. Several challenges were faced and tackled, such as ensuring the material could cure properly in humid climate of Tabasco. The mix had to be adjusted to account for the environmental condition, which could have impacted the settling time. Now, I'll be concluding the presentation stating some points as follows. First is that 3D printed buildings represent a significant advancement in civil engineering and construction technology. By embracing additive manufacturing, it can address critical challenges such as labor shortage, environmental sustainability, and affordable housing. There are some hurdles to overcome, such as developing suitable materials, updating building codes, and ensuring quality control. The potential benefits are significant. As the technology matures, it will be an integral part of the construction landscape. Here mentioned are the references which I have used for my presentation. Thank you for getting along with me the whole presentation. Hoping you have a good day ahead.